All right, so today we're doing a review of exam 2. I've got exam 2 from fall 23 here, and it shouldn't take us the entire time to go through it, so I've got some extra exercises at the end if we want. Otherwise, same deal as last time. It'll open up 1 second after midnight Friday morning. It'll close 1 second before midnight Friday evening, so you have a 24-hour window in which to do it. It should only have to take you maybe an hour, but if you want to do the first part, go back, eat lunch, take a break, whatever, come back to it later. Submit and resubmit as many times as you want up until the due date at that midnight, okay? Otherwise, no collaboration with any individual, so no hack pairs, no lab pairs, nothing like that. No use of AI tools, except for that rubber duck debugger that's already in the CS50 over here, right? You can use that. All right, regular help hours will be held that day. But LAs will not give you help like they would on a lab or a hack. They'll just answer general administrative questions. Otherwise, good luck. So here's the problem statement. There we go. Cora is a water manager at Future Industries, a utility company. As manager, she has tasked you to write several of these functions. She wants you to write the following set of functions. All the prototypes will be in this waterutils.h, which we provided. Note the to-do here. We didn't provide documentation. It will be graded based on documentation, design, and style, just like anything else, right? So 9 points for those things, and then the remaining 75 minus 9 would be 66 points based on correctness, all right? And then we did give them a water utils tester here with a bunch of test cases already done so that you didn't have to start from scratch on that. And then all your code is going to be placed into a source file of this name. Right? All of your functions must have proper documentation, good style, etc., run with no segmentation faults. Right? And it will be submitted to code post, and there will be automated grading just like usual. Right? So the first exercise here is a volume converter. Some of the Earth tribes are a bit unsophisticated and want water usage reported in cubic feet and gallons instead of the standard liter. So we're going to write a function to convert a volume of water measured in liters, L, into cubic feet, C-U-F-T, using this formula right here. One liter is equal to 0.03 and change cubic feet. 1 gallon is equal, or 1 liter is equal to that many gallons right there. We are going to write this function right here. Right? I'm not going to go ahead and write any of the documentation here, but my suggestion is that you write your documentation first. In fact, this is what you should be doing, because writing the documentation is simply just taking what are directions and then summarizing them in your own words. And by the very act of summarizing them in your own words kind of gives you a blueprint for what your function needs to be doing. Right? All right, so I'm not going to do that, though. Instead, I'm going to go ahead and, new file, waterutils.c, right? And I'm going to implement this function now. Before I do that, though, what needs to be at the top of this file here? I can increase the size. Okay, so author documentation. Good. All right. Includes, right? So what am I going to include? Standard. STD. Lib. Well, if I end up doing any I/O, yeah, I'll include that. Right. I don't know if I'm going to do any I/O yet. I don't know if I'm going to do any math yet beyond multiplication, division, whatever, right? My H file. Include waterutils.h using double quotes instead of the normal Langle-Wrangle, right? It's a bit too big. There we go. That's comfortable. When I write a function now in week 8, what is the first thing I should do? Error handling in general, and null pointers would be one of those. But let's go down the line here. What could happen with liters? What could go wrong with liters? Negative. Yeah, if it's negative, right? Is there any such thing as negative 2.5 liters? No. 0? 0 is fine. 0 liters is 0 gallons, right? All right. What could happen with cubic feet? Negative. So let's think about that for a second. Is that a normal variable that I can check negative values? No. What kind of variable is that? A pointer. So what values should I check for that are dangerous for a pointer variable? Null. Cubic feet if that's null, right? Or what about gallons? Same problem, if that's null. All of those are error conditions. Now, if that's an error condition, I could separate this into 3 different error conditions and return 3 different values if you want to. But should I return what here? Should I return 0? 0 indicates what? No error, right? This is definitely an error. So keep it, I mean, I mashed my keyboard. I could return that. What makes more sense? 1, right? Just keep it simple. Yeah?
Oh yeah, I'm kind of getting confused with the Boolean, because then the Boolean, like, false is 0.
Yeah, this is not returning true or false, though, is it?
No.
This is returning an error code, right? So, yeah, it's somewhere in here. But this is going to be an error code because we're going to convert liters over to cubic feet and gallons. I'm not asking a yes or no question here, right? I'm not asking, like in your current hack or whatever, I'm not asking, does this thing lie within this region, or does this array contain 5? Right? That's a yes or no answer. This is not a yes or no answer. I've got liters. I want you to convert it to those 2 things. And I want you to tell me if something went wrong. Right? That's the return type here. Now, we haven't written the code for the function yet, but what should I do immediately at the end? I already did my error checking. If I got down to the end on line 13, is there an error? Nope. So what should I return? 0. Now let's go back and write our code. Right? I want to convert that liters into cubic feet. I know that it's not negative, otherwise I would have already returned. So I can go ahead and say cubic feet is equal to liters times, what was it? This thing right here. Copy, paste, there. Right. So one problem and a couple of improvements that we can make on this one line of code here. Cubic feet, is that a regular old variable that I can set with regular old code like that? Nope. What do I need to do to that pointer to make it into a regular variable so I can set it? Dereference. There we go. Improvement number 1. What is that thing right there? It's the what is it? Cubic feet per liter, right? So, but if I just showed you that number with no context, would you understand what that number is? No. Let's give it a name. Let's use a define macro. Define. What is it? Liters per, or what? No, it would be what? Cubic feet per liter. Is that right? Okay. There we go. Likewise, I'm probably going to want to do that for gallons too. And so that's define gallons or gal per liter to be that thing. Okay? And now I can use human readable terms over here in my source code instead of those magic numbers. In fact, I don't even need to go back and cut and paste it. I already know what it was called because it has a label. Gal per liter. Right. Okay. If you want to, you can align these up. I meant to look that up. There's a name for this when you align all the equals. Does anybody know what it is? Okay. There's for the style here of lining these things up. And then you can align that up if you really want to, but I don't like that. Oh, not later, but what is it? Liters. There we go. Right. Now I could try to compile this right now, right? Water utils, but I haven't written the rest of them, so I don't even know if it will compile. Oh, it will. But am I going to be able to test it? I guess I could. I could test the first one, this convert volume here, but that would mean that I need to get rid of all this code. So delete it. Is that a good idea? No. Let's just go ahead and comment it out for now. Now, review on compiling. If you're compiling a library, you use the -c flag, waterutils.c. That will produce over here a waterutils.o file, an object file. But before I go on, what else should I have done here? What other flag should we be using every time we compile at this point? The wall flag. Okay, good. No warnings. Right. Now, how do I compile with this water tester? GCC, not the C flag because I'm not compiling. I am compiling, but I'm building an actual executable a.out. So waterutils.c dot O, and then water tester. And what else? Wall. Right? Okay, good. I'm getting a warning here that I'm not actually using this error code. That's okay, I don't care about that though. Right? I could print it out and see what it is and see that I get a 0 or a 1, right? And verify that that's correct, but whatever. So, is that correct? 42 liters is 1.43 cubic feet. Let's ask, you could ask Google if you want. 42 liters to cubic feet. Help me out there, Wolfram Alpha. 1483. 1483. What about gallons? 11.1. Oh, that's close enough. All right, so I have reasonably high expectations that this function is done and good. If I hit it in, it's not going to run because the rest of it ain't done yet. So let's do the next one. During a drought, each household in a village is restricted to a certain limit of liters of water. Right? The current water usage of each household is tracked and stored in an array of size n. For example, if we have 5 households here, then we're going to have an array of size 5. And this means that the first house used 3.5 gallons, the second house used 8.5, not gallons, liters, 10 liters and 0 liters. They haven't used anything yet, and they've used a whopping 20 liters. Okay? So write a function to determine the remaining amount that each household is allowed to use. In this case, I didn't put it here, but in this case, the limit is 10. Right? So for example, 3.5, they've used 3.5. So how much do they have left? If the limit is 10, 6.5. They've used 8.5, so their remaining limit is 1.5. They've used 10, meaning that they don't have any limit left at all, so 0. 0, they haven't used anything, so their limit is 10. And here, they've used 20. In other words, they've used more than their 10 liters of water. We do not have a negative here. Instead, it is reported as a 0. They've reached their limit. There is no more allotted, right? They don't have negative 10 liters remaining in their quota or whatever, all right? We're going to write a function, this function right here, that takes the limit and takes an array of doubles of size n and returns a brand new array of the same size but with these numbers instead. Right? Their limit minus the amount that they've used, except that if that's negative, it should be reset to 0. Good? All right. And let's go ahead and write this over here. Right. Give some more room. There we go. There we go. There. Hopefully that'll stop bouncing up and down. Again, oh yeah, go ahead.
I have a question about the first function that we wrote.
Sure.
Why would it be an integer rather than a void function?
Because if it's a void function, how can I tell you something went wrong? Right.
Okay.
Right. So that's an option, right? We could have designed it like that, or I could have designed it like that, but then there's no error handling possible, right? It'd be like, what's one void function that we've seen? I can't think of any true void function that we've seen. Like square root, that returns a double. Even malloc returns a void pointer. So it's kind of a waste, right? No, I want to know what happened. Was it successful or not? If I look at the cubic feet and gallons, I want to know, are those the true values, or did something go wrong that screwed it up? Right? So back to int. Right? All right. All right, so get remaining water. What's the first thing I should do again? Error checking, right? So if the limit is, I don't know, negative, if the usage is, what could the usage be if that's wrong or bad? Null, because it's a pointer. If or what could go wrong with n, the size of the array? Yeah, so like 0. Can you have an array of -4 integers? No. You can have an array of 0 integers. That does make sense, but not at the same time. You can have it, but why would you want it, right? So if any of those things happen, we'll return 1? That indicates an error, right? But what's the return type here? It's not an integer. It's not even a regular double. It's a pointer. What is the only pointer value that indicates something went wrong? Null. Okay. All right. So let's outline this. The first thing I need to do is I need to create this thing right here. I need to create an array of that size. So create a new array of size n to hold the new values. Dot, dot, dot. Right. 2. What do I do after that?
Compare your new array.
All right, so I need to populate my new array by looking at my old array and just doing some math, right? So for each element in the usage array, right, dot, dot, dot. Right. Now let's outline this. If they have exceeded their usage, set the new array value to 0. Else, set the new array's value to, so how did we get 6.5 out of this thing here? 10 minus 3.5, or in general? Limit minus usage, and here I'll put I here, because we're going to iterate over each one of them. Okay. 3, return the new array. Okay? So, create a new array. How do I do that? Is this correct? Result of n. That's a double array, right? And it has a size n, right? Yeah, you want a dynamic array. You witnessed this in your lab last week. What happened with this? When I think return random, generate random array, we had this code there, and it was wrong. Why was it wrong? Where is this array allocated right here? In the stack, right? Remember, you've got a stack and you've got a heap over there. If it's allocated in the stack, a stack has stack frames. What happens when we return back from this function, get remaining water? What happens to the array that's in that stack frame? It gets deleted, right? So this is definitely wrong. We need a pointer. What's that thing that we call? Malloc, right? We typecast the return value to match the thing on the left-hand side. Right? And what do we pass to malloc? Big enough? Yeah, size of? Yeah, int or double. In this case, am I doing an integer array though? No, it's a double array. And how many of them do you want? n. There we go. I'm going to jump down to here immediately and return result so I don't forget. All right. Now let's do 2. For each element in the usage array, this is just an idiomatic for loop. For I equals 0, I is less than n, I plus plus. Right? That should be this is going to be the most common loop that you ever write in your entire lives. Right? You're going to write that thing forever and ever and ever. Right? That's why it's idiomatic, right? Muscle memory. You'll immediately type that out every single time without thinking. Right? Okay. If their usage has exceeded, so usage of I is greater than the limit, then what should I set it to? Results of I is equal to 0. Right? Else, right? Now what? I put it in my pseudocode up here. Right. Result sub I, oops, is equal to the limit minus the usage. Okay. And there are ways to simplify that, but that's how we wrote our outline here, so that's what we will stick with. Okay. I'm going to leave the comments for now, but should we see this stuff in your final submission? No, that's Cruft. All right. Okay. We could test it now, I guess. So let's come over here. That's from the handout right there. Right, there we go. And so let's recompile everything. You don't have to retype either, by the way. right? If you've seen me doing this, right, you just have to hit the up key, the up arrow, and it goes throughout your entire history here, right? So I'm going to go ahead and go with that right there, right? And then hit the up key a couple more times to compile everything together, get the same morning as before, and then I will type that out, right? So 6.5, 1.5, 0, 10, and 0. That looks like it to me. All right. Rainfall monitors from the Airbender tribe take regular measurements of rainfall in an area represented by two-dimensional grid, an n by m. So n rows, m columns, right? And store it as a 2D array of double values. For example, here's a map, a 3 by 5 map. 3 rows, 5 columns. When the data is not available, a negative value is used. So for example, right there, there's no data there. There's no data there. There's no data there. Right? But one of them is -1, one of them is -5. Don't read anything into that magnitude. Those are not numbers that we should pay attention to. Those are numbers that we should ignore. Right? Write the following function that takes this map and computes the average rainfall. Right? We're going to put that into a pass by reference variable right here. So in the above example, originally there were 15 3 by 5, but 3 of them were invalid. So we kicked those out, and we only have 12 valid data points. If you add up all those 12 valid data points, you'll get 7.325. So the average is going to be 0.61, right? Units of rain. The actual units are irrelevant. Okay? All right. How am I doing this two-dimensionally? How am I doing this two-dimensional map right here? That's a 2 pointers. It's a pointer to a pointer, right? Okay. So let's come back over here and start writing it. Again, what's the first thing I should do? Error handling. What could go wrong with the map? Could be null. What could go wrong with n? Less than 0. What could go wrong with m? Same answer. What could go wrong with average? Null. Right? We're computing the average. We're not expecting anything like this. For example, this would be wrong. If the average, dereference it, average is less than 0. Right? We don't care what value is stored in that bucket. We're going to be replacing it. We're going to be computing it. Right? Null. Okay. Then return 1. Right? Otherwise, return 0. Everything went fine. Right? All right. How do I iterate over a two-dimensional array?
Create your, yeah,
Okay. Int I equals 0. It was 0. I is less than, what's the first dimension? N. I plus plus. In other words, for each row. Now for each column in that row. So I need another for loop. Can I use I again? J equals 0. J is less than m, because that's our number of columns, J plus plus. Right? If you ever find yourself doing something like that, right, it's going to be real hard unless you really stare at it. So what I like to do is I, J, J, O, J, right? Just as a sanity check there. Right? All right, let's check if it's valid. If the, what is it, map sub I, J is valid, then add it to a total and maybe something else. Okay. So help me out here. How do I translate that as valid? What did the handout say?
anything less than zeros.
Is invalid. So what is the opposite of that? It is valid if it's greater than or equal to 0. Right? Remember, we do have an example in here of there was no rainfall in that place, but that's a valid data point that you should take into account. Right? All right. Add it to a total. Do I have a total here? Int total. So add it to the total. Total plus equals map sub I, J. Is that all correct? Yeah, whoa, whoa, whoa. What about that? Okay, good. One problem is, what value is there as of line 49? What is that thing called? Just remember, dead beef, dead beef, dead beef, right? It stinks, right? Why? Dead rotting beef, right? What should I have set it to? 0, right? What's the other thing that's wrong with this? Yeah. 2.5 plus 3.5? Oh, that would be an integer, but yeah, it's hard thinking of random numbers. Right? That's why we give you that random number generator in your last lab. Right? All right, that's much better. Maybe something else? I'm going to leave that here. To do something else? Question mark? How do I compute the average?
Put them all together and
All right, so I've got them all total. And then the average would be, I'd have to divide by the number of valid data points, right? Over here, was that 15? Nope, there were 3 invalid data points. So I probably need to keep track of that as well. Int, num valid points. Right? Also, initialize that. So now what's my something else? Num valid points, valid points, plus plus. Good. All right. Then I can divide by, I don't want to type it anymore. Copy paste. All right. All right. So there's my average. Now, first of all, anytime you're doing division, what do you have to be on the watch for?
Parentheses.
Parentheses, there we go. But anytime you're doing division, what else do you have to be? Division by integers, which happens what? 10 divided by 20. What happens there? Truncation. Do we have a truncation issue here? One of them is a double, one of them is an integer. So we're good. All right, that's my average. How do I set it? I need to set this average equal to that. Is that correct? Average is what kind of a variable again? The map was an array. This is just a regular old pointer. So how do I change this regular old pointer into a regular old pointer, a pointer into a regular old variable so that I can set it, dereference. All right, this will probably work. Let me go ahead and restore all of the tests now. Right. By the way, that other trick there, block selection and comment out entire blocks, all I'm doing is command, oh, this is a Mac, so command and then /. Back and forth toggles it. I'm sure that it's like control on Windows. Right. Right. So let's go ahead and recompile that, and run it again. Hey, that looks familiar. That's from the handout. Right. Because we just gave the same data up here. Right? Yeah.
How many activities do we have for the test?
About the same. It's, this is 3, so 3. Yeah.
What does the C flag do exactly?
That compiles but does not produce an executable file. If I didn't have the C flag here, it ain't compiling because it says there's no main here, right? And indeed, do you see a main here? Nope, it's just a library. So the C flag will compile it into this object file, just like on somewhere on the system there's a math.o file. Not really, but there's a shared object file somewhere. It's not called math.o. They compile everything into one big giant file and then put it on the system. There is an object file there, and that's what the C flag is used for. Note, I did not use that for all of this. Why? Because I don't want to compile it into an object file. I want to produce this a.out file. All right. So run that. Was it still working? Yeah, that's all working. Okay. If I handed this in, one, I would lose points here for cruft comments. So let's get rid of them. And 2, this function would fail because I've not thought about all of the corner cases here. Okay. Yeah, this looks pretty good for error handling. Now, if it's like an empty matrix or empty map, then none of this would actually execute. Right? What's one potential problem with this line right here? Yeah.
Unvalid point is 0.
Yeah, what happens if there are no valid points? I gave you an entire table full of -1s. What's dumb valid points going to end up being? 0. And division by 0 is inf undefined nan, not a number. Right? So let's check for that first. If num valid points is 0, then what's the average? 0. It's not an error, but you gave me a bunch of invalid data. The average of that invalid data, according to the handout, is 0. There, else that. And now it'll pass, but I don't have it set up. And that was it. They're just additional instructions down there. Submit your files, not your tester file. We don't care about that. The reason that we give you a tester file, though, is so that you have at least one test case and you can build off of that. Right? Because if you didn't, you'd have to write your own, of course. And if there was something wrong, for example, I don't know, N. No, let's go N and M here. Let's find out what happens there. GCC. Oh, I need to compile them all together. There, and now GCC that. Get that out. Okay, good. I got a segmentation fault out of that. What should I do next? Give up? Give up. Okay. So what are the tools that we've covered so far? The wall flag didn't come up with anything, right? Because I was using that in the entire time. So the compiler can't determine this, or what happened, right? Other than that, and that's a completely different thing. So what's another what's another tool? Where did it even happen? Right? We know that it happened here because you saw me make that stupid change. But where is the seg fault even happening? What? Valgrind. A dot out. Okay, we've got 2 errors in 2 different contexts, etc. It had still reach it, blah, blah, blah. Let's come up here to the first one. It's always start at the top, right? Where is it? Terminating with a seg fault. It happens somewhere in average rainfall. All right, I need to focus on that method or on that function, right? But did it tell me the line number? Why didn't it tell me the line number? It doesn't know the line number because I didn't tell it to preserve the line numbers. G flag. Right? G flag. Right? Now let's run valgrind again. If I come up here, now it will tell me what line number it happened on. On line 47. Focus your attention right there. Okay, well, I'm accessing the map I and J here. I, J, 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 that looks good. Oh, N and M, right? There we go. Right. Now, if I still didn't see it by just focusing on this one area, then what's the next tool that I should bring up? GDB, right? GDB, I can say, make a breakpoint at line 44 here, right? So we've already compiled with the G flag, so let's do that. Let's restore this back to what it was. The wrong what it was, right? So GDB A dot out, and let's go ahead and break at what was it? Water utils dot C line 44. We'll stop before that, right? And layout source, right? Run, right? And refresh because it donked up. Right, there we go. All right, now I am stopped at this line. Let's print the total, right? Okay, that's 0 because I initialized it. Let's go ahead and print M. Oh, 5, print N. Oh, I see here. It's a 5 by 3 array, right? No, it's a 3 by 5 array, right? And you just have to have some discernment skills, when using this tool, because it's not going to tell you you mixed N and M there, right? You're going to have to look at it and check it out, right? Next, or next. Next, remember that N is the shorthand for that, and I think that we're going to get a seg fault. We're not going to get a seg fault in the first iteration here. Next, 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 next. Actually, you can continue. Right, there we go. Okay, now we got a segmentation fault here. 3, 5, there's the memory address, backtrace full. Right, there we go. And you can see, oh, okay, I got up to a total of 4.375 before it donked out, right? It donked out when I was 3, so it got down to the 4th line. Ah, there we go. There were only 3 lines, right? There were only 3 rows, and it got down to the 4th row right there, I, on the first column. That's when it donked out. Right? If you want to, we can go ahead and set another breakpoint here. Quit. All right. Break at line, what was it? 47. If I was 3 and J was, what was it, 0? Yeah. All right. And so run from the very beginning here. Yes. Continue from that breakpoint. There we go. Refresh this. And you can start taking a look around. Print I, print J. Right? Print map of, what is it? I, J. And it'll tell you, you can't access that memory. Why? Because you're on the 4th row, first column. Right? So the hints here. Right? Again, it doesn't help you fix it, but it helps you diagnose it. Right? Yes, quit. All right, how much time do we have left? Okay, we've got 10 minutes. I don't know if we can do this or not, but let's go demo here. All right. This will give us at least more practice here. I don't know if we're going to get it done, but it'll give us more practice. What I've done is I've taken some stuff from Lab 7 here to generate a random array to print it out so we can do stuff with it. I'm going to generate a random array of size 5, and I want to implement what's called a cyclic right shift function. So if I have, say, 1, 2, 3, 4 elements in there, I'm going to shift them all to the right. So that it looks like 4, 1, 2, 3, 4. What happened to 4? It got shoved to the right, shifted to the right, and then it came back around. It's cyclic, okay? Basically, I'm rotating this thing. If you ever heard of like ROT26, the super secure encryption code, rotate 26. There are 26 letters in the alphabet. You scramble them up by rotating them around 26 times. That's a joke, right? Because where does A end up? Right back at A, right? So ROT26 is the ROT26, right? Is the joke there, all right, haha. All right, so let's go ahead and write this function here. Later on, we'll go ahead and implement this function, which is more general. Okay. All right. I'm going to be changing your function, so let's just go and make it a void function for now. We won't worry about error handling. What should I call this function? What does it do? Cyclic right shift? Sounds good to me. Cyclic right shift. All right. All right. What should it take as input here? An array, of course. Const int star array. What about that const there? What's the purpose of const? That it stays the same, right? That you're not going to make changes to it. But I am going to be making changes to it. I'm going to shift everything down by 1 and then take the guy in the end and put him over here. Right? So, no const there. And then what else do I need if I'm working with arrays? The size of the array. N, size, whatever. Size of ARR or N or size or whatever. Let's just go with N there. Okay? Now, before we write it, let's set up our test case here. I'm going to cyclically right shift this randomly generated array. Right? Then I'm going to print it out again. Right? We gave you enough scaffolding in your Lab 7 and that you can use and reuse for testing your Hack 7. So make full use of that. You can generate a random array of size 10 and print it out. See if your contains within works. See if your whatever else was in that hack. I forget now. Reverse. I think, reverse. Right. Okay, so help me out with this. Again, what I want it to look like is this. If you start out with 1, 2, 3, 4, I want to shift everything over. So what if I started at the beginning here? What if I moved 1 down? So here's my result. 1, 2, 3, 4. What if I moved 1 space over? yeah, I wouldn't have my 2, right? I'd be overwriting data before I move it. So probably don't want to start at the left end. What if I started at the right end? First of all, let's take this 4 and put it off into a temporary variable up here. That frees up space that I can move 3 over. 3 comes over here. That frees up this in order to move 2 over to here. That frees up this to move 1 over here. Right? And finally, where do I put that 4? Right at the beginning. Right? So I whiteboarded it, right? I would have done this on an actual whiteboard, but I don't have it with me. I didn't bring my iPad today, but we'll eventually start using that for illustrative purposes. Right? Okay? So, outline this. Start at the end. All right? Save off the last value into a temporary variable. In fact, I can do that before starting at the end. Start at the end and shift each element I to I plus 1, right? Or some other way. Yeah, go ahead.
So, would it be considered wrong if you were to just make another array and then return that array?
Hold
Or
that
just-
thought. We're not going to be able to get to it today, but yeah, hold that thought. Right? That'd be way easier anyway, but no. Actually, for this one, that would probably not be the way to go, but for this one, most definitely. Right? Right. All right, so shift each element I to I plus 1. Right? Then at the end, what do I do with that temporary variable? Place the temp variable back into array sub 0. Right? So there's my outline. And of course, to do, reconsider error handling. Okay. Save off the last variable. Int temp is equal to arr sub n. Is that the last value? We start our counting in computer science at 0. Therefore, the last number is going to be n minus 1. All right? Start at the end and shift each element up by 1. So 4, it's not going to be a regular idiomatic for loop here. Where am I going to start I? Okay, that would still be at the that would still be at the beginning, right? I want to start at the end over here. N minus 1. Okay, that's what you were probably saying. Sorry, I didn't hear you. Right? I is something something. I. Now, if I'm going to work from the right end to the left end, what's going to happen to I? Minus minus. Right? How do I shift each element I to I plus 1? Right? Array sub I plus 1 is equal to array sub I. Right? That's got me rethinking this a little bit, right? But that's okay. We can do this. What is it? Array sub 0 is equal to temp. Now, I still have not figured this out. When do I stop? But let's also make sure that we're doing this correctly here. And the way that you do that is by going back to your whiteboard with an actual example. Right? This example right here, say. I'm going to bring this down here and we're going to look at this. So that is indices 0, 1, 2, and 3. So n here is 4. So where do I start? I start at 3. And I set I is going to be 3, right? Plus 1, so array sub 4 is equal to array sub 3. Does that sound correct? No, why? How many things do I have? 4. Do I have an index 4 over here? No. So where should I start if I'm going to use this as my statement? Minus 2? Let's try that. All right, so if I start at n minus 2, what is n? 4. So 4 minus 2 would be 2. Right? Plus 1, that gives me 3, is equal to array sub I, which we've said was 2. So I'm copying 3 into 4. Does that work? Yep. All right. When do I stop? When it's greater than, less than n? I'm starting at this end and I'm working my way back. So, greater than or equal to, I have no idea, 0. Now you need to think about what's your last iteration. What if I went down to and including 0? Array sub 0 plus 1 is equal to array sub 0. Right? So simplifying that becomes that. Is that what I want? Yeah, I'm taking the, I'm shifting this one over here to this one right here. Right? So that's another way that you can start debugging stuff. You're putting in actual values. Now, if I were on a whiteboard, I would write them all out. I would say, what happens when I is 1? Or, you know, on the first iteration, here's I, here's j, whatever else is there. Write it out, diagram it. Okay? I think that's good. Let's see if it works. GCC WAL flag demo.c. A route out. That was a randomly generated array. Is it been shifted cyclically by 1? Yep. Works on my machine. Is that a guarantee that it works? If I had handed something in like this and I got a seg fault, you would know, oh, well, it works on my machine because it's simply not crashing. Right? What should I do? I should run it through val grind to see if I get a clean bill of health here. There we go. Val grind, a dot out. Right? There is one error, but that leads to that's because of a leak, a memory leak here, right? That in the main here, I have not freed up the array, so let's go ahead and take care of that array, free that array, GCC it, run it through val grind again. Clean bill of health. So all of my index values here are probably correct. Now, going back to your question here, how would you go about doing the cyclic right shift k function here? Right? Very quickly here, I'm just going to go ahead and copy, paste this, right? And put in k instead. Right? What this by k? It's not going to shift it over 1. It's not going to shift it over 2. It's not going to shift it over 3. It's going to shift it over k times. Right? My solution to this is just simply going to be calling this other function here, because I don't like working. Right? If I've already got a function that shifts it by 1, what if I called that function k times? For int I equals 0, I is less than k, I plus plus. I plus plus. Right? Cyclic shift right, array n. I do it k times. Right? Let's see if that works. Up here in main, I'll call that, and let's shift it over twice now. GCC. Darn it. I need to bring this up here and make a prototype, and then I can do it. There we go. All right, did that shift over too? 5027 is now over here. What happened to that 7852? 7852. That seems like a good solution. Right? And anybody starting out in a CS1 program would probably do something like this. But let me show you the consequences of it. I'm not going to print it because I don't care about big giant arrays. But let's go ahead and kick this up to 1 million. Right? So it's going to generate an array of size 1 million, which is not big data. That's less than 4 megabytes. Oops. Cyclic shift right by k. Oh, come on. Did I not recompile? There we go. Oh, come on. What is wrong with you? And oh, I know. It's only by 2. So n divided by 2 is what I wanted. Because it was, there we go. So I've created an array of size 1 million, and I want to shift it half over. So 500,000 times. So that the last 500,000 are now over here, and the first 500,000 are now shifted over here. How long do you think that that's going to take to run? It's only 4 megabytes of data. Right? That's nothing. It should have been done in a fraction of a second. Right? So the difference between like a boot camp coder, right, or somebody who's just taken a CS1 course, and and a computer scientist, which you are on your journey to be, right, is seeing a terrible, horrible, unacceptable inefficiency like this, right? We've got a loop within a loop basically here. So 1 million things are being shifted 500,000 times. How many things are being done? 1 million times 500,000, we call those trillions? All right, so 1 million times, or 1 million times 500K. That's, okay, it doesn't understand what I'm saying there. So 1 million, okay, 10 to the 6th times 5 to the, no, all right, 1, 2, 3, 1, 2, 3. There we go. How many is that? 500 billion, like you said. I should have trusted you. Right? 500 billion things. How long do you think it'll take to do that? An unacceptably amount of long time. Right? This will probably take hours. Right? Whereas if I had done this correctly from the start, maybe temporary space, it would have been done in a fraction of a second. Right? We'll revisit this later when we start looking at efficiency and performance testing and stuff like that. Right? But otherwise, good luck on your exam on Friday. Right? Don't forget that there's exam on Friday.